Welcome to Olympian Water Testing, giving you the best in water analysis. Today we're looking at the Safe Drinking Water Foundation, SDWF, and the relationship between ammonia and chloramine. What is it? So students actually did this, but it's quite interesting to see. So they learned about the sources of ammonia in groundwater, the consequences of high ammonia concentrations of water supplies, and the manner in which these problems are usually dealt with. And students learned about biological filtering as a way to use bacteria to remove ammonia from water. And they also learned about chemical relations between chlorine and ammonia, which results in the creation of chloramine. And they also have the information about chloramine. So what did they do? So the interesting thing that comes out of here is the data, which is the chloramine concentrations were found by subtracting the free chlorine concentration from the total chlorine concentration. Chloramine concentration of the first beaker was 10 milligrams per liter, and the concentration of the second beaker is 0 grams per liter. And in the salt sugar example, the mass of salt in the first beaker is 0.1 liter times 20 milligrams per liter, 2 milligrams, and the mass of sugar in the second beaker is 0.1 liter times 4 milligrams per liter. And then when they're mixed, the final solution will contain the very same amount of salt, 2 milligrams of salt and 0.4 milligrams of sugar. But the volume increases to 200 milliliters if the final concentrations of salt and sugar are calculated. The 10 milligram salt and sugar, students realize that by doubling the volume, the concentrations are diluted by 50%. And even when there is no chemical reaction that takes place, this indicates when the mixing of chlorine and ammonia samples, the concentrations will reduce to 10 milligrams per liter free chlorine and 2 milligrams per liter ammonia due to dilution before the chemical reaction begins. Then the 10 milligram free chlorine will be available to react with the 1 milligram per liter of ammonia. And this will leave 1 milligram per liter of ammonia and 0 milligrams per liter of free chlorine. And the 10 milligrams per liter free chlorine used in the reaction will turn into 10 milligrams per liter in chloramine, since the final free chlorine concentration is 0 milligrams per liter, and the final total chlorine concentration is 10 milligrams per liter as well. So one of the most important chemicals for water treatment process is ammonia. And the chemical is found in ammonia, NH3, and it's something that many water treatment facilities deal with one way or another, and it's common for ground and water surfaces to contain ammonia because it can come from so many sources. It can be added to soil by nitrogen-fixing bacteria as part of nitrogen decay of plants, animals, agricultural, and industrial processes, and it's highly soluble, so it gets dissolved and transported by surrounding groundwater. In the areas that do have ammonia in their raw water, it's a problematic source of chlorine demand. For each milligram of ammonia, the water takes 10 to 15 milligrams of chlorine to react with it and get rid of it. And the reaction between ammonia and chlorine is much faster than the rate of the chlorine kills the bacteria. So you can't use chlorine to disinfect water that contains ammonia. Fortunately, the most widely used method of removing ammonia is to add chlorine in a process that is called breakpoint chlorination. And chlorine is continuously added to the water until all the ammonia in the bacteria has been removed, or in other words, till the chlorine demand has been met. But only works if there's a little bit of ammonia and there's more than 0.3 milligrams per liter of ammonia in the raw water. So much of the chlorine has to be added to get rid of it, and that it would result in dangerous levels of chlorination byproducts. So that's a little bit interesting to see that experiment and how chlorine and ammonia react and what they do to each other and how chloramine is created. So with all that being said, if you want to know if any of this is in your water, ammonia, chlorine, chloramine, how much, then you have to have your water periodically tested.